I'm not going to try and sell you anything today, so don't worry. I'm going to have a bit of a candid talk about SDN really and what's going on in the marketplace and what I see out there. SDN's been talked about quite a lot lately and everybody's talking about SDN and everybody's going different routes on it. So we're just going to have a little chat about what we think is going on and what SDN's all about really. Ooh. So everybody knows SDN is all about separating the control plane from the forwarding plane, and that's what everybody's banging on about. This is what we need to do, but it's not really. That's how it does it. What SDN's really all about, I believe, is to try and make your network easier to manage. That's the whole idea of it. At the moment you've got a big network out there, lots of routers, lots of switches, lots of everything, and each individual element is difficult to manage in its own space. So the idea of SDN was to try and make everything a bit easier to use. Let you utilise your network a lot more efficiently than what you're doing at the moment with current IGP tables where, as we've just been hearing about, all traffic goes down a certain path, but making it so that centralised management will let your traffic flow in the best manner suitable for the network, where there's bandwidth available, where there's low latency, different types of traffic going in the right direction. Let you virtualise your network on the fly, create new networks, handle different customers' traffic or different types of traffic differently, send them different ways. Much easier to do when it's all centralised rather than having to try and get every individual element around the network to talk about how it's going to send different traffic in different ways. Gives the opportunity to try and earn more revenue from the network by prioritising specific traffic and charging for that. Charging people for getting low latency, charging people for having higher bandwidth for specific traffic flows as opposed to all the traffic. So individual applications, getting them being able to get the traffic they require to get to the endpoints where they need it, but using your network the best way. And to try and reduce your vendor lock-in. That was one of the key things about SDN really. Get rid of the expensive vendor lock-in, get any tin you want on the network, the cheapest tin you can to do the job, but still have it centrally managed. So that's kind of what I think SDN really is all about. Yeah, it's separating the control plane from the forwarding plane, but that's just the way it's done, not really what you want, why it's done. If we just have a quick look at the current hardware model, because it's kind of key to the way SDN really looks. At the moment, most of your elements out there have got a bespoke operating system running at the top with different processes and protocols running, each one of these individual little silos of code that do different jobs. It could be BGP, it could be quality of service, it could be any different types of processes that are running there. And this is where the vendors at the moment have spent all their money. The tin's pretty commodity these days, so really all the money they're spending is going into this operating system at the top. Okay? Underneath that, you've got your hardware. Typically these days it's I/O interfaces, depending on what you need in your network. They've got forwarding tables, layer 2, layer 3 forwarding tables built into them now, so they do very fast forwarding. One of the key things the manufacturers have all put in the middle now is a hardware abstraction layer. That means they can buy the tin at the bottom for the forwarding interfaces from anywhere. They've got their operating system at the top, which they've spent all their money creating. So a simple hardware abstraction layer lets them add any bit of tin they want to talk to their operating system. They can bring out new interfaces very quickly, add it in. So that's kind of the model most tin is running on these days. You've got your operating system at the top, your tin at the bottom, and a hardware abstraction layer telling the tin what it's meant to be doing. If we look at a kind of SDN architecture, it's surprisingly similar. The tin at the bottom now turns into tin with some built-in code on it that's SDN aware. So you've still got your same forwarding tables built into it in hardware, you've still got your I/O interfaces, but now you've got just a little bit of code sitting on there that will talk some flavour of SDN. So now that becomes a separate individual little box. That's where commodity comes in. Once you've chosen your SDN flavour, then you can buy that. Your operating system at the top, which has all your modules in it, now become apps. And these now, individual modules can be taken and put at the top of the network. It's the same modules doing the same code. It's still a BGP engine, it's still a quality of service engine, it's still SNMP, it's still whatever, but it's just now becomes an application that sits at the top. And in the middle now, we take away this hardware abstraction layer that we used to have in the bit of tin and we put in an SDN controller. It's pretty much the same. Your tin's still at the bottom, your application operating system is still at the top, but now you've got a controller in the middle which handles the applications talking to the tin, which is very similar to what we had in the old hardware model. The controller's got two different types of interfaces on it. Naturally, you've got a northbound API so that you can talk to different applications. So anything that's coming in from the network into the controller can access applications at the top depending on what the traffic requires. Where SDN and the open approach to SDN kind of falls down a little bit is on the southbound API. Because everybody wanted OpenFlow to be an open standard, lets everybody use everything the same way. But unfortunately, those applications at the top, the vendors at the moment have spent a hell of a lot of money developing those, and they'd rather like you to keep on using those if you could. So they've also spent a lot of money on the tin at the bottom, and they'd really rather like you to carry on buying that. So the openness of SDN is kind of getting a bit swayed by every vendor going, well, maybe there's a different way of doing SDN. So there's many different southbound APIs out there now. You've got OpenFlow, VXLAN, XMPP, BGP, the IEEE are bringing out I2RS out in February, I believe that's due out. And everyone's doing it slightly differently. If you take the VXLAN route, for instance, you now need to build your normal layer 3 network that you're building today, and we'll overlay tunnels on top of it. But if we went back to the original model of, wasn't it supposed to make the network a bit easier to run? Well, now you've kind of got to run the same network you're running today in exactly the same way, just so you can overlay a VXLAN network to be able to get virtualization on top of it and be able to do traffic flows on it. So is that really the best way of going about it? It's a very difficult route. And that really is where it's kind of running out. But if you look at this model and say that if we've got the tin separated and you have all the applications at the top on a single pane of glass, then yeah, it should make running your network a lot easier to do. You can control everything right from the top. If we quickly go back though to the original tin model, there's probably something we've forgotten which is out there already today. Is that a lot of the vendors out there now are putting orchestration engines and management engines on top which control everything that's going on the network anyway. So you can have a single pane of glass with widgets and with templates for service creation which will go out and configure the network for you. So part of what SDN is offering you in the future is kind of available from individual vendors there at the moment today. So some of it's there, some of it isn't already today. If you want to look at using the network properly, with your SDN model, for instance, you're now making routing decisions or traffic forwarding decisions at a central place, so that a single person operator or even APIs upstream to your own billing systems or your own OSS systems can now choose which path particular traffic needs to go down. You still have to do a traffic identification at the edge to find out what that traffic is, send it up to the controller, let the controller and the applications at the top decide where you're going to send this traffic. But take that a next stage forward, and if we could in the future include the application or the client that the customer is using or the end user is using and extend those APIs from the top of the stack into those applications, so that if someone fires up at a video session, for instance, have the video server tell the SDN controller or tell the applications at the top, I now have this traffic from this source going to this destination. I want for this traffic this level of latency, this level of jitter, I need X amount of guaranteed bandwidth, and let the network then say, where have I got bandwidth available that meets all these constraints, and then dynamically set that traffic flow up. Now that's something you can sell. You can easily sell that to customers and say, I can guarantee latency and traffic for your individual flows, not everything from your site to another site, but per flow that you pay for, I can do that, but you don't have to do anything to do it, because the APIs will allow you to do that. Taking that forward, that's a very nice way of doing it, because then you configure your network up and let the traffic define what there is under boundaries that you've got set on the network. Also, there's a few issues that comes to that. It's great if all the traffic stays inside your own network, because you can control all of the traffic flow inside your own network. As soon as you get to a boundary onto somebody else's network, then what do? I'm not giving you answers, it's food for thought here. What do? You've got to try and keep that quality of service or that traffic flow that you've charged for. You've got to try and keep that moving. How do you hand that off to another provider, another network, to ensure that same level of quality as it goes over to another network? What happens if you hit a boundary with a network that isn't SDN? Then you've got to try and keep that flow. If you hit a boundary that is another SDN network, are you both talking the same SDN? Is there something in the middle there that's going to convert your requirement into what they want to see for their requirement, because they may be using a completely different model? So whilst it sounds like a brilliant idea, it's great at the moment if you're inside your own network, but handing that off is going to be kind of tricky. So if you want to move on to SDN and you were thinking about making the leap and going there, what do you need to do? We've talked that there are many flavours of SDN, be they layer 2 overlays or layer 3 overlays using VXLAN, etc. BGP signalled VXLAN, which sounds very much like BGP signalled VPLS. There's OpenFlow, which is a different version again, different orchestration mechanism, etc. So really you need to choose your flavour of SDN that is for the type of network you're running. Okay? Once you've chosen that, you need to choose the applications at the top. What do you need in your applications to move the traffic around your network? Data centre networks obviously probably have less applications required to run than maybe a WAN network, where you need a lot more protocols to interact around the network. But are you going to be limited in the apps which you're able to run because of the flavour of SDN that you've chosen to go for? Are you limited on the vendor that you can use for those applications based on the flavour of SDN that you've chosen? And is your peering point, is it traditional point and shoot, or are you going to hope to interface your SDN with other networks? Once you've chosen that, you choose your SDN controller. Now, this isn't an easy one to do, because now you've got to get a controller in the middle that will work with the applications that you've chosen and with the flavour of SDN that you've chosen to run on your network. You've got to talk to the northbound APIs and any other APIs you've written, your southbound APIs down to the tin, and there is another line at the bottom which you can't see, which says now it's down to the tin. Once you've chosen your applications at the top, you've chosen your flavour of SDN, you've chosen your SDN controller that you want to manage all of this network, now you've got to do your tin. But you could be slightly limited on your tin, because what flavour of SDN have you chosen, what bit of tin out there now supports that flavour of SDN? You could go and make your own, which some people have done, and then you're pretty much okay. But I think at the moment it's the vendors are still pushing you towards use ours. We'll give you everything we've got today, plus we'll give you the new stuff if you keep on using our tin, please. It's really losing, I think, the overall view of what SDN was meant to be all about, the openness and being able to use anything with anything. So I think it's a difficult way of moving forward there. And as that moves on. Is it doom and gloom? Probably not doom and gloom at the moment. SDN's still out there. A number of networks have gone forward with SDN. Google are using it. Facebook have said they're going to be looking at building their own tin for doing it, but that's going down the building your own tin route as opposed to going down there of using something that's already out there. This is my earlier version of the slide, so it's got a few X's on it. There's also other people out there, smaller networks, that have looked at doing it, started doing it, playing with it. It's probably the bigger providers who'll look at it first, as I say there, those that have got the money to spend to see if they can actually save money doing it. It's a big learning curve out there doing it. Will it be the future? Yeah, I think some form of it will probably be out there. It's probably unavoidable now. There's so much talk about it. People who start moving that way, a lot more people. I don't think that the number of southbound protocols that we see at the moment is going to be the end. There's going to be a lot more out there coming. Maybe the IEEE standard will make some differences out there. I know they've kind of stretched that slightly by including a format for how the FDB is going to be made, so that the table sizes and table layouts of FDBs are going to be similar in their standard across hardware, which may make the use of bespoke tin or cheap tin much easier to do. I think SDN will take off more probably when it stabilises a bit more, when there's more interoperability, when people, or when tin is available out there. And what may be push it forward actually, is when hardware is more readily available as built-in operating systems, so it is cheaper on the network, and then that hardware at the edge may push the choice of SDN protocols that people are going to use because of the cheap and availability of hardware. But is it something to push into? Lots of things that are knee-jerk these days, and I know in London there was an issue with getting traffic through the streets. So what did we do? They came along with a bendy bus. It was a great idea at the time. It looked like you'd get a lot more people and a lot more traffic from one place to the other. Bit ill thought out because the pipes weren't big enough. It didn't go anywhere. Ill thought out, but its worst thing is things that went really, really wrong. And when it starts getting to this stage, these aren't making revenue. So I think it's making that choice of SDN is really a big choice to make sure that when you're going forward with it, it's going to continue making you revenue. It's not going to crash and burn like these. That was all for me. Just a candid approach to what's going on with SDN.
Okay, thank you.
Any questions? Hello.
Okay, we have time for just the one question.
Hi there, Rob Shakir from BT. So there seems like a lot of hype here, and I think there is. Can you explain to me, why would we centralize all these features when we've built some distributed systems to be able to actually scale and be resilient to faults? We've centralized things before and they generally didn't work. They didn't scale, they fell over when large events happened and there was large amounts of reconvergence. The second thing I'd sort of note is that the traffic-based steering, flow-based steering, we've been able to do this for a long time, and we've actually been able to do it in a way that we give distributed systems hints as to how to route their traffic so that it both scales and you get the flow-based steering. As someone pointed out in IRC, it's quite a complex way to operate a network, so there's challenges around that. I've been involved in multiple networks that have run that, and we haven't overcome that management problem. So I think that's a pretty large area to address. Plus, maybe the technology that we have to do it in a distributed fashion doesn't scale. So I don't see anything particularly new in what you've just talked through. I just see moving complexity around, which is gesturing by some vendors who don't necessarily have the technology that we use today to solve these problems.
Absolutely. No, please, I'm just trying to point out where SDN is at the moment and the goal of what SDN was trying to achieve. And yeah, you can do a lot of what we're doing at the moment. A lot of the flavours that are out there look very similar to protocols that we're using at the moment, or some vendors are using at the moment. There is the goal, I think, was to try and make it centrally managed to overcome that management issue so that you don't have individual network elements to configure and just have centralised management of the whole lot. But yeah, I agree with you. So a lot of it you can do today, but that's not really in the spirit of SDN.
Okay, we had one more question here.
Hi, Paul Bruce, Virgin Media. My colleague mentioned 3 times scale. What's your view on its potential scale? Are we talking millions, tens of millions, or hundreds of millions of flows?
I think one of the issues of scale with SDN is how many controllers do you have, how many controllers do you push out, how do you federate your controllers in the end. No, seriously, you're not going to end up with a single controller managing an entire large network, so there will be handoffs between controllers. You'll probably end up with clusters of controllers managing certain parts of the network, and you could argue that to get the scale with the controllers you need, you'll end up pushing it further and further and further down, so it could end up looking like what you've got today. But I think the idea of SDN is to try and centralise that more and reduce the management elements that there are in the network and the number of elements that need to be managed to control the flows of traffic. So scale-wise, it's a difficult one, and a lot of it will depend on that southbound protocol that you're using, as well as how that needs to be managed across the elements to create those paths. So I don't think there's any answers yet. I think it's time will tell what happens with SDN.
It's that magic word, hype.
Absolutely. SDN is there.
Okay, thanks, Jace.
Thank you.